Now let's see this one, right? This should be 1 over 1 minus rho over 1 plus r, which is 1 over 1 plus r minus rho over 1 plus r, which is 1 plus r over 1 plus r minus rho. So, good. Okay. Sorry. Yep. Perfect. So super. So thank you. Excellent. It requires a lot of courage to go to the whiteboard, and I think you did an excellent job. And so thanks. In Germany, we knock on the table when we applaud in academia. So in the theater, people applaud this way, but in academia. Okay, so let's talk about the expression before we continue, right? And I'll reserve this part of the blackboard, or the whiteboard, for the picture. So we have time, and we have output following this path. Right? People are living happily, and then there's this shock, and then output returns, right? This is what output does. Right? And this is period t. What happens to consumption? Well, consumption, let me use the red color. Consumption drops and stays at this level forever. Now, what is the reason for this drop? So why does consumption drop? And why does consumption not drop as much as output? Now we're talking not about math, we're talking about the intuition. So why doesn't consumption drop to this level, but it only drops to that level? What is the economic reason for that? Give it a try. No, but give it a try, right? Just the reason is that income drops, so the present value of income drops. So consumption has to drop, but it doesn't drop by as much as output, because what is already anticipated is that consumption will recover, that output will recover, right? So at that time, and this is the perfect foresight assumption, the rational agent anticipates that output will go up again. Okay, so it's like, you know, you have a low income for the next 6 months, but then income will go up again. You will not reduce consumption drastically because you know that your income will recover. And so that's exactly what happens. Now, please note that for some time, consumption is higher than output, and for some time later on, consumption will be lower than output. This will be something very important, right? This is not. Now, the next thing is, what is the role of rho? Pardon? The persistence of the shock, exactly. So the shock is very persistent if rho is high. Now let's look at two extremes. Rho is equal to 0. Then consumption is y minus r over 1 plus r delta. Now, if rho equals 1, then consumption is y minus delta. Now, what is this situation? Now, this situation is when you have a permanent income shock. So you have output going down, and you have consumption going down by the same amount. If the shock is permanent and it doesn't go away, then there's no way that you can smooth consumption, because if someone tells you, look, the income drops and it will be like on the lower level for the rest of your life, you cannot smooth consumption because there's nothing to smooth. And in fact, the drop in consumption is the higher rho. The more persistent is the shock, the stronger the drop in consumption. So when I learned modern macroeconomics, this was the moment when I thought, gee, this is really super cool, right? This is where those dynamic models make a difference, because they distinguish between short-lived shocks and long-lived shocks. This goes back to Milton Friedman's permanent income hypothesis. Right? Milton Friedman, one of the most influential economists of the 20th century, he said consumption does not depend on current income, it depends on permanent income. The alternative view was the view of John Maynard Keynes, who said consumption depends on current income. So if people have low income, they consume very little. If they have high income, they consume a lot. What Friedman said is this is wrong because it does not consider the future time path of income. Let me give you an example. Suppose you're getting a WhatsApp message by some distant relative who you actually don't know. And that person tells you, look, I like you a lot, and that's why I give you $10,000. First of all, you're a bit suspicious, and you check, and then you realize that the money is already on your bank account. So what would you do with those $10,000? Would you go to Ho Chi Minh City and party and spend it all in one night, or maybe a couple of days? So how much would you spend on the same day of these 10,000? Give me a number. Suppose you get $10,000. How much do you spend right now? 1,000? 50%, 5,000. Okay. Okay. Good. Okay, so store that. Now suppose you're getting this WhatsApp message, and suppose you see the 10,000 on your bank account, and you ask the question, oh, thank you, but what about tomorrow? And you get an immediate WhatsApp message where the person says, tomorrow you will get another 10,000. And then you say, oh, and what about the day after tomorrow? And the same person says, you get another 10,000. And you say, wait a minute, does that mean that I will get $10,000 a day for the rest of my life? And the answer is yes. So how much of the 10,000 would you spend right away?
$1.
Pardon?
$1.
One, no, we're talking about 10,000.
100.
100 only.
100?
Yeah, what? Look, who would spend more than?
Yeah.
How much would you spend? 5,000 or?
Yeah, 9,000.
9,000. Okay. I would actually spend 10,000 because in the first case you had a transitory, temporary, positive income shock. You had 10,000 going up, or your income going up, but you expected it to go down as well again. And so your consumption reaction was very weak. Now, if the income shock is permanent, then your consumption reaction is much stronger because your permanent income has changed, right? And this is exactly what's going on here, with a sad difference that here we're not talking about positive income shock, we're talking about a negative income shock. But the negative income shock, if it's the persistence of the income shock determines how far consumption goes down. And in the extreme case where you have a permanently negative income shock, consumption goes down all the way because there's no way of smoothing consumption. Okay, so that's the logic. Okay, now let's go into the evolution of the net international investment position. Did anyone give it a try? Yes. Pick whatever pen you want to, board marker you want to use, and whatever region you want to use. Yeah, it's a bit heavy there. So, okay, you manage. Ah, this is the one that doesn't work. The needle in the haystack. There's some stuff, right, look. Okay, you use this one. I'll deposit them here. There's an R on top, on the numerator. It's an R. It's not a 1. It just copied something. It's this here, and there should be R. Okay. Super. So let me check my own stuff. Yep. Okay, thank you very much. Terrific. Now, in fact, we can go further than that, but I didn't ask you for it. Okay, cool. Now let me. This is perfect. Thank you very much. So you all did great jobs. I'm impressed. And I actually if we proceed like this, then this is very, satisfying because it's in German universities. It's usually you say, does anybody volunteer, and then people discover that the pattern on the table is super interesting, and they start exploring it, and you say, is there anyone interested in doing it? And then it's very hard to get people active. Now, I really appreciate that you did that. Now, let me add something, and that's something I did, last night, so it's not in the presentation, and I think it's so this is correct. Let me go to this part because I need some space. So I'm just copying what Lynn. The funny thing is about this, if I have that, I can read. But I don't see the distance. If I don't have it, I see the distance, but I can't read. This is okay. So you have bs plus 1 equals ys, or no, let me r over 1 plus r minus rho to the power of s minus t, delta plus 1 plus r bs. Good. This is what Lynn derived. Now let's do this step by step. So let's say s equals t. Then you have bt plus 1 equals r over 1 plus r minus rho minus 1, because then rho to the power of t minus t is 1, delta plus 0, because bt is 0. And we get r minus 1 minus r plus rho divided by 1 plus r minus rho, delta, and of course the r's cancels out, and we get rho minus 1, 1 plus r minus rho delta, which is smaller than 1, 0, if rho is smaller than, or if 0 is smaller than rho and smaller than 1. Okay, now let's go to the next period, s equals t plus 1. Well, here things are a bit more complicated. I'm using the blue color. bt plus 2 is r to the divided by 1 plus r minus rho minus rho, right? We have rho, we don't have 1 because this is rho to the power of what is it? Yep, exactly. And here we have rho to the power of. Yep, exactly. It's t plus 1. That's what. Thanks. Thanks for saving me. And then we have 1 plus r, this thing here. One plus r minus rho delta. Now, it takes a little bit, but what you get in the end is rho squared minus 1 over 1 plus r minus delta. Yeah. And if you continue with that, you realize that Bs is rho to the power of s minus t minus 1 divided by 1 plus r minus rho delta. This is, right, so you go from rho minus 1 to rho squared minus 1. You go to rho, in the next period, you have rho to the power of 3 minus 1. You can crank it out. What this describes is a process where the net international investment position takes this evolution, right? This is basically t plus 1. So at the beginning of t plus 1, there's this downward jump, and then it goes downward and downward, downward, and then it settles on a long-run constant level. So this is Bs. So what we can do is the limit of Bs for s going towards infinity is 0 minus 1, because if we let s go towards infinity, we get 0, 1 plus r minus rho, and that's delta, and that's minus 1 over 1 plus r minus rho. And this is exactly that level. So that's minus 1 over 1 plus r minus rho delta. So the net international investment position goes down, and then it goes down further, but it doesn't go down explosively. It settles on some long run constant value. Finally, the current account balance. The current account balance, let me squeeze this in here. Oops. Right? the current account balance is what Lin derived, and that's perfectly correct. But you can also write it as ys plus rbs minus cs, right? That's just writing, that's just the same. It's just saying using this, right? And then here you have the current account balance as bs plus 1 minus bs. And then you move this to the left-hand side, and then you have the expression that I'm showing you here. Now, we have y minus rho to the power of s minus t delta. Then we have this result, which says we have plus r rho to the power of s minus t, no, nonsense, minus 1, over 1 plus r minus rho, delta minus, and now we use consumption, and consumption is given up here, y minus r over 1 plus r minus rho delta. Now this looks complicated, but it isn't, right? What we get in the end, so we see that the y cancels out, right? That's what Lin also did. And what we get in the end is the current account is rho minus 1, rho to the power of s minus t divided by 1 plus r minus rho delta. So it's negative for 0 smaller than rho smaller than 1. And most importantly, the limit of the current account for s going towards infinity is what? Zero. Because this thing here goes towards 0. So in the long run, the current account is 0. So if we complete that picture, we have, and now I have to check in order to not make a mess out of that. You have the current account. Well, we have the current account going down and then returning to its long run average to 0. And we have the net international investment position, and eventually settling on this. This is what the picture looks like. And this is period T. Now this is the whole picture. And this is basically the picture I'm showing on slide, I think it's 351. And now let's again think about what's going on here, right? And the question is,